So in this playlist, so I'm planning to create a playlist specifically for the graph algorithms. I will go through all the graph data science or the graph algorithms that are there in Neo4j. Today I will start with the centrality category, and within that also the article rank algorithm within centrality. Now, what is this GDS? So the Neo4j graph data science actually is a library that contains this graph algorithms. And these graph algorithms are categorized into these categories: centrality, community direction, similarity, pathfinding, right? Topological link prediction, right? And if we go through them, what these are: the centrality, it determines the importance of distinct nodes in a network. Community detection, right? If you have seen Microsoft Graph RAG, that actually does community detection. I think it uses Leiden algorithm there. But these are some algorithms within community detection which evaluates how groups of nodes are clustered or partitioned. Similarities, which computes a similarity of pairs of nodes based on neighborhoods or properties of the nodes. Pathfinding finds a path between two or more nodes or evaluate the availability and the quality of the paths. This mostly used during route optimizations and all. Topological link prediction is finding hidden links, determine the closeness of a pair of nodes using the topology of the graph, right? We'll look at the centrality and within that article rank today. So let's go through it. So within centrality, again, we have a lot of algorithms, right? Harmonic centrality hits and all. We will go through article rank today. Article rank is a variant of the page rank algorithm, which measures the transitive influence of nodes, right? To understand this, how it differs from the page rank, let me actually create a graph. So this is a graph of, I've created a sandbox environment in Neo4j, creating the graph. Let me now visualize the graph. So the way article rank differs from page rank is, so this is not correct. And return all of them, right? So, yeah. Okay. So if I look at this graph, right? So this node, okay, so advance in machine learning has two citations, right? So this will get a high rank. Now this cites this, right? So if I see this 2 plus this, right? So in article rank, this will have a higher rank compared to this one, right? Because here there is no input, right? There is no incoming, but here this one has the direct incoming from there, and there are two other nodes, right? That also will have a influence on this one, right? So in case of article rank, higher order nodes, right? The influence rate, it's more, but in case of page rank, this would have got a higher rank, right? Because in page rank, what happens is, so if I go to the page, right? The page rank follows the assumption that relationships originating from low degree nodes have a higher influence than relationships from higher degree nodes. Article rank is just little opposite to that, which lowers the influence of low degree nodes by lowering the scores being sent to the neighbors in each iteration, right? So, and this is the formula to create the article rank. This is the damping factor. The damping factor is actually used to take out certain scenarios in the networks, right? Like there is three scenarios. One is a spider trap, rank sync, and dead end, right? What this means is, so spider trap is like this, like if a network, right? If there are no relationships from within a group of pages to outside group, for example, this one, right? It is not going to any other group. This is a spider trap. Infinite cycle between two nodes that creates a rank sync, and dead end is like if from a node there is no other outgoing relationship, then this is a dead end, right? Damping factor is used to help with these considerations, right? It's a probability, it's a number from 0 to 1, and uh, the default value is 0.85. So what it actually interprets it as a that web surfer or a article surfer, let's say, sometimes jumps to a random page or random article, so that they are not get stuck in the sinks, right? So the it's a 0 to 1. If you take too low, then it's also not good. If you take um, close to 1 also, that is also not good, right? Usually the value that is taking is 0.85. That's a um, like I think that's a learned number, that it has been seen that 15% of the time people will surf to a random page, right? But the damping factor is used to take care of these three types of considerations, right? Now, let's see how we can um, use this function in Neo4j, right? So I have this, so I have created this uh, network of articles, right? Now, the first thing that we need to do is we will take this graph into, we'll project this graph into a graph called my graph. I can name it anything. I named it my graph here. So I'm projecting this graph, article cites article, into my graph, right? So let me run it. So this is a in-memory graph now. Now on this one, I'll run my um, article rank algorithm, right? To run the article rank algorithm, I'll use the stream execution mode, right? Where I'm saying jds.articleRank.stream. I'm giving the name of the graph that I just created in memory, yielding the node ID and the score, right? Then in like when I created the nodes, right? If you see um, the properties of the graph that I had, right? Title is a property, right? So when I projected that, right, I had the title also. So I am returning the title of the graph and the score, right? So let's see. Let me run this, right? So these are the article rank, right? So advances in machine learning got the highest score because it had advances in machine learning, right? We had two citations, right? Then it should be this because two citations coming from this and one citation coming from this, right? So transitive influence of this two to this will be there. So neural network should be the second one. Let's see if that is true. Yep. Applications of deep learning is the next one because it has only one citation and this does not have anything, right? So that is how it is. Understanding AI. It's got the lowest article rank, right? So this is how the article rank uh, graph algorithm works, or you can use like this. You can also use it within Python as an SDK, right? And the other execution modes are stats. If you just want to see what is the statistics of the article rank, like the one that you run. So stats is another execution mode. Here we use stream. Write is another execution mode. When I say write, it will actually write the property within the graph, right? For example, let me actually do the write. Right? So this is the write. So if I use this, the write property, centrality, will be stored in that graph database as the property of the nodes. Right? So right property centrality, right? So if I run this again now, you'll see there is a property that has been written now, uh, centrality property, right? It got written in the database, right? And the other is muted. When you say muted, the property will be written in the in-memory graph, right? So that's how the that's how the article rank graph works. In the subsequent recordings, I will go through the other algorithms also. So next, I'll start with the articulation points and all. That's all for today. Thank you.